And now we are going to discuss what is adjacency list representation. Okay. Adjacency list is already done. Incident matrix. Okay. Now, how to represent incident matrix? Now, in case of incident matrix, we'll do this like this. Matrix. So it will be like E1, E2, all the edges. Okay, E1, E2, E3, E4, E5 and E6. Now in this side we will have V1, V2, V3, V4, V5, right? Now what are the two edges that are connecting E1? Okay, now V1 and V2. Okay, V1 and V2. So it will be 1 and 1, only V1 and V2, and rest of them will be 0. What are the two vertex connecting E2? E2 is connected by V1 and V4, and rest of them will be 0. Now for E3, now E3 is connected between V4 and V5, so it will be V4 and V5, and rest of them will be 0. For E4 we have V1 and V5, V1 and V5, and rest of them will be 0. For E5 we have V5 and V3, V3, V5, and for E6 V2 and V3, right? Done. So this is called incidence matrix. So in our last class we learned adjacency list, adjacency matrix, and also graphical representation, and in this class we learned how to make one incidence matrix. Using any of these techniques we can represent any graph in a computer memory or in any other data storing devices. Okay, and in our data structure and also in algorithm we also use these techniques to represent any graph and to analyze any graph also. Okay, thanks for the class.